Okay, so what is a greatest common factor? Talk about it real quick. I'll give you 10 seconds in your groups. Go ahead. Greatest common factor. Okay, who can tell me? Who can tell me? Biggest number that can. Greatest number that can be multiplied to get both numbers. That is an accurate statement, but a weird way of saying it. That is true. That's not usually how somebody defines it. So I'm not going to say it's wrong by any means. But there's an easier way of saying it. What is a factor? So Colin said it's a number that can be multiplied to get that number. What's another way of saying that? So we made factor trees, and what were we looking for?
Prime numbers.
Okay, we were looking for numbers that multiplied to get the bigger number, right? What was another way of doing that some of you did on your calculators? You would divide on your calculators, right? So the easiest way to explain greatest common factor is to say the biggest number that will divide into a set of numbers. Okay, so the biggest number that will divide into the set of numbers. So the biggest number that will divide into 22 and 30.
Oh, I thought that was 22,030.
No, it's a set of numbers. It's just 22 and 30. So what's the biggest number that divides into 22 and 30 both? 2? You think so? Okay. Well, let's look at 2 first. So the easiest way to do this, guys, to make sure you have the GCF is to say, okay, I think my GCF is 2. So we think 2 is the biggest number that divides into both of those. So what if I divide 2 into 22? What am I left with? 11. If I divide 22 into 30, what am I left with? 15. Is there anything that divides into both 11 and 15? No. So we have the GCF as 2. Okay? And remember, when I'm thinking of GCF, I'm thinking a number that divides. Okay? So later on, once we start factoring, in order to factor out a GCF, we are dividing it out. Okay? So that's just a little nugget of knowledge that I want you to hold on to. Okay? Alright, so you guys do 2. Don't stress out if you can't think of a gigantic one at first. Use the same method that we just did. If you divide it out and you still have something you can divide into those 2 remaining numbers, then divide that out and take it together or combine it together to make your new GCF, okay? Okay, so I'm sure you all geniuses and you figured it out, but I'm not going to let you tell me, okay? Say I'm like, okay, I think these are both divisible by 2. I'm going to guess low. I'm going to say 2. Okay? So I say, because I just want to show you this, just as a little FYI. So GCF is 2. I think it's 2. So if I divide 56 divided by 2, that would give me 28. If I divide 160 by 2, that would give me 80. Is there anything that can divide into 28 and 80 both?
Yeah.
Yes, what? 2 or 4. So now I say, okay, I can divide both of those by 4. So I'm going to bring that 4 out and put it with my GCF. So now if I divide 28 by 4, I'm left with 7. If I divide 80 by 4, I'm left with 20. Is there anything that can divide into 7 and 20? No. So what is my GCF really? 8. Because I multiply 2 times 4 and I get 8. Okay, so in case you can't find the GCF right out or outright, You can always take another piece out and then just multiply the two pieces that you took out together. Okay, so that's just a little FYI. All right. So now we know how to find the GCF of two numbers. What if we're trying to find the GCF of variables? Okay, so remember, GCF is the greatest common factor, the biggest thing I can divide out of every piece. Okay, so I want you to just go through example 1 together with your partners. Okay, so just go through example 1 together with your partners. Go step by step so that you can find the GCF of variables. Go ahead. Okay, so x to the 4th y in expanded form. Be 1, 2, 3, 4 x's and a y. X squared, y squared in expanded form, x, y. So here's what I'm thinking, okay? Say I have 4 markers and Joe has 2 markers. Okay, so I say I have 4 markers and Joe has 2 markers. If I have 4 and Joe has 2, and Lauren would like to borrow markers from us, but she wants to be fair. She wants to make sure and take the same number of markers from both people because she has to be fair. What's the biggest number of markers she can take from both of us? If I have 4 and Joe has 2. If I have 4 and Joe has 2, how many can she take from both of us? To be fair. Can she take 4? No, because Joe doesn't have 4. How many can she take? 2 from each of us, right? So if there are 4 x's here and 4 x's in the first term, 2 x's in the next term, how many could we take from both fairly? How many do they have in common? They just have 2. I could take 2 out and still be fair. So 2 x's, so that's x squared, right? And how many y's do they have in common? How many y's could I take from both of them being fair? Just 1. So a single y. So what is the GCF here? Yep.
X squared y.
Yep, that's it. X squared y. Okay. So you don't necessarily have to write them out in standard form every single time. If you understand that x to the 4th is really 4 x's. Okay. So go ahead and try these numbers 3 and 4 together with your partners. Go ahead. Okay, so number 3 here. Out of x and x to the 3rd, how many x's can we take out? Just one single x. And out of y to the 3rd and y, how many y's can we take out? Just one single y. So x, y would be my GCF there. Okay, number 4. Out of those two terms, how many x's can I take out? None, right? The second term does not have any x's, so I can't take any x's out for the GCF. That just means my x is not part of the GCF, which is okay. All right, y's. How many y's can I take out? If I have 4 and 5, I can only take out 4. So y to the 4th. And then z's. How many z's can I take out? I can take out 2 from both of them, so z to the 2nd. All right, now let's put it together. I'm not even going to help you. I don't think you need my help. Okay, so go ahead and do example 2 and try these 5 and 6 together with your partners. So example 2, try these 5 and 6 together with your partners. Make sure you do the number and then go through and do the variables, okay? Okay, so for example 2, what's the biggest number I can take out of 4 and 10? I can divide out of 4 and 10. 2, right? So my GCF number part is just 2. And then I have 3 x's and 2 x's, so I can take out 2 x's. I have 10 y's and 2 y's, so I can take out 2 y's. So 2x squared y squared. It's as simple as that. Okay. Try these number 5. What's the biggest number I can divide out of 8 and 24? 8. So I have 8. And then I have 3 x's and 2 x's, so I can take out 2 x's, x squared. 8x squared would be my GCF. Okay, and one more. So now I have 3 terms, and the question came up, Mr. Craw, what if I have a negative? Okay, that doesn't really affect anything because you can still divide anything into a negative number. The only time it changes anything is if they're all negative, then generally it's most common practice to take the negative out. But unless they're all negative, you don't really mess with it. Okay, so biggest number I can divide into 4, 12, and 8? 2? So if I take a, what?
4.
Okay, so if I took a 2 out, I would see that I could still take more out. So 4 is my biggest number I can take out here. So 4 is my GCF number part. I have 3 x's, 2 x's, and a single x. So what's the most I can take out of all 3 of them? Just a single x. So 4x would be my GCF. Let me ask you a quick question. If I took 4x out of all these, what would I be left with? So if I took 4x out of 4x to the third, what would I be left with? 4 take out 4 would be nothing, or 1, and x to the third take out an x. I'd be left with x squared. What about 12x squared if I take out 4x? Well, 12, remember, take out, I'm dividing it out. So it's 12 divided by 4? 3. And what's x squared divided by x? Just an x, right? So 3x would be left there. And then what about negative 8x divided by 4x? Negative 8 divided by 4 is?
2. Negative 2.
Negative 2. And what's x divided by x?
X.
Nothing. Okay? All right, so this is kind of what we are doing on the backside, okay? Because you may say, oh, Mr. Craw, that's all fine and dandy. Who cares if I can find the GCF? Okay? What we are really going for here is not just being able to find the GCF. That is an important skill. Okay? But this is not the end goal. The end goal of this whole unit is being able to take something that is complicated and break it down into much simpler parts. Remember when we were doing radicals not that long ago? And we saw like the square root of 120. It was difficult to see what I could take out of the square root when it was just 120. So what did we do in order to figure out what we could take out of the radical? We simplified it down into primes, right? Because if I break something big down into smaller, easier to work with parts, it makes my life a lot easier, okay? It's kind of the same thing here. So let's flip over to the backside and see what we're talking about. So I see this expression up at the top. Okay, this 3x to the third minus 12x squared plus 15x. Okay, I see that up at the top. That looks pretty difficult to me to work with. It would make my life a lot easier if I could break this down into simpler to use parts. And we're going to do that by factoring. Okay, and we're going to take it step by step by step. So today we're going to learn just the simplest type with GCF. And then we'll move into more complicated types later on, okay? But that being said, I want to do a problem over to the side really quick that I would like you guys to do. So just do this problem really quick. How about that? So anywhere you have some open space on your worksheet, just do that problem quickly. Okay, so I distribute this in. What is 2x times x? 2x squared. And then what is 2x times 3? Plus 6x. Okay? All right, now let me ask you, what is the GCF of 2x squared and 6x? So what could I, so here I'm going to go backward now. So what's my GCF? What can I divide out of 2 and 6? 2. How many x's can I take out? 1. So what if I divided both of these by 2x? And I said, okay, I'm going to divide 2x out and I'm going to stick it out in front of the parentheses. So what is 2x squared divided by 2x? My 2's would cancel. What's x squared divided by x? Just x. What is 6 divided by 2? Plus 3. And my x's cancel. You see what I just did? See that? How it's the same? You guys all see that? Okay. So what we're learning today is how to undo distribution. Okay? How to undo distribution. So there are times when it's best for us to see something that is all put together, and there are times when it's a lot easier for us to see something in broken down little parts. So we've learned how to take several pieces and multiply them together and make a big long expression. But now we're going to look at how to break a big long expression down into its simpler parts. It's called factoring. Okay? you have a question?
Couldn't you just have done the GCF before you made 2x squared?
What?
Couldn't you have just already made the GCF? Is that equal?
You mean from up here?
Yeah.
Yes. The problem is, problems like this won't be given to us like this. Okay? I kind of did the full circle, but this would kind of be useless if we did all of this in class. I just did this to show you that they're opposites. Okay? So before, problems were given to us like this, and we had to make this. Now problems are going to be given to us like this, and we have to go back down to this. Okay? So let's actually look at an example here. Let me get rid of this. So now I have this expression, and I want to look at how it is similar and different to the previous problems. So how is this problem similar to our previous problems that we did on the back side, or on the front side, I guess? Sarah?
The constants are combined with like a variable with an exponent.
Good. So we have different terms here, right? With constants or numbers, coefficients, and variables with 3, 12, 15, and then we have some x's in there too. How is this one different than the problems on the front side? Sarah, for the clean sweep?
They have like subtraction and addition problems in it.
Yeah. You guys notice that? On the front side, we just had a term, comma, term, comma, term. We were just finding the GCF. Now we have addition and subtraction in there. Okay? So now we're actually taking this expression and factoring it out. So let's copy this problem down here. And let's look how we actually factor this. Okay? So every time we factor, we're going to start by trying to factor out a GCF. Not every problem will have a GCF, but that's what we always want to start with. Okay? So does our problem here have a GCF?
Yeah.
Yeah? Okay. So what divides out of 3, 12, and 15?
3.
3. And are there any variables I can divide out of all of them? Yeah, they all have a single x. So my GCF is 3x. Okay? And remember, since factoring is the opposite of distribution, my answer should look like a distribution problem. I always want my final answer to be equivalent or the same as my initial problem. Okay, so I'm not just factoring out a 3x and throwing it away. It still needs to be present in the problem. I'm always going to take that GCF and stick it out in front of my parentheses. So I have, actually, make sure you leave yourself some room underneath the red problem. So my 3x is always going to be out in front of the parentheses. And then what's left after I factor out the 3x is what's going to go inside the parentheses. So remember, distribution, we always took this piece that was out front and multiplied it into the parentheses, into every piece, right? Now we're going to go the opposite direction. We're going to take our GCF, we're going to factor it or divide it out of all three of those pieces. Okay, so let's show that. So divide by 3x, divide by 3x, divide by 3x. All right, now let's finish it. So 3 divided by 3 is just going to be 1. X to the third divided by x is x squared. So that's my first piece, and bring down your sign. Okay, now negative 12 divided by 3 is negative 4, so negative 4. And x squared divided by x is x. And then, so now for my third term, 15 divided by 3 is positive 5, so plus 5. And x divided by x is gone. So I can move my parenthesis in here. And there's my final answer. What would happen if I distributed 3x into the parentheses?
You would get that.
Yep, I should get that, okay? So if you ever have a question of, ooh, did I do this right or not? You can always distribute the GCF back into the parentheses and see if you come up with the original problem. Okay. Can I get a comfort level how you're feeling right now? 0 through 3. Lots of 2s. That's good. That's a good place to be right now, okay? All right, so that being said, you have 4 try these problems to do together with your partners. Go ahead. Okay, so on number 7, my GCF was 4x squared. So I stick my 4x squared out in front of the parentheses and divide each piece by 4x squared. And then you can see after I divide 4x squared into both pieces, what's left goes inside my parentheses, 2x minus 3. Questions on 7? Okay. Here's number 8. Okay, so there's number 8. You can see on number 8, my GCF is just 5a. Just a single a can be taken out of all three of those. So here, as I'm dividing 5a out of each piece, my 5a goes out in front of the parentheses. And then what's left, a to the third minus 2a plus 5 is left inside the parentheses. So any questions on 8? Okay. Here's number 9, and there's a little bit of a tricky piece on number 9, so make sure you're paying attention here. My GCF is 9, so I stick my 9 out in front of the parentheses. Oops, I guess I forgot to write this in, didn't I? Divide by 9, divide by 9. So 36 divided by 9 is 4, and my y stays. What is 9 divided by 9? 1. So it is super important that you put your plus 1 in here. Okay, because if you just wrote 9 parentheses 4y, if you distribute that back into the parentheses, what would you be left with? Just 36y. You wouldn't have 36y plus 9. So you have to make sure anytime a piece fully cancels out, you still put a plus 1 placeholder in its place. Okay? Alright, so any questions there? Alright, and the last at number 10, GCF is 6h. I divide 6h out of each piece, stick it out in front of my parentheses, and you can see what's left inside the parentheses.
This isn't that hard.
No, it's not. Okay, do we have any questions? Can I get a comfort level after you've practiced a little bit?
2 and then like a pinky.
Good. Good, good, good. Okay.
Like that.